All right, we are going to talk about some vocabulary that is specific to quadrilaterals. All right, or at least more specific. Okay. The first few terms are going to be just general polygons, but then we're going to apply them to quadrilaterals. Okay. So the side of a polygon is a line segment. Okay, so line segment. And the example in the picture at the right, we've got AB is a good example of a side, or CD, maybe. Okay. We'll just go with the other two also. AD and BC. Okay, all four of those are sides. They're just the line segments that make the polygon. Okay. A vertex is the point where two sides meet. Okay, so for instance, point A or B or C or D, each of those individually is a vertex. Okay, when we are naming the polygon, we name them with consecutive vertices. So we could say A, B, C, D is a quadrilateral there in the right. Okay, consecutive sides are two sides that are adjacent or next to each other. All right. And these consecutive sides share a vertex. All right, so for instance, in the picture at the right side, we'll say AD and DC. That's just one example of a pair of consecutive sides. Okay. Talked about it this previous unit. Interior angles are angles on the inside of a polygon created by consecutive sides. Okay, so if we're using the consecutive sides we did up there, AD and DC, those are consecutive sides that form interior angle D. Okay, right here. All right, consecutive interior angles are two angles that are, again, adjacent to each other. Right? But the consecutive interior angles are two, they share a side. Maybe, come on. So, for instance, we'll do two different colors here. Angle ADC or angle D here, that's one interior angle. Okay, another interior angle that would be a consecutive interior angle is going to be angle C right here. Okay. And again, consecutive means they're right next to each other. And you can see both of those angles share that side DC. Okay. A diagonal is any line segment that connects two non-consecutive vertices. Okay, so example at the right here, if we are to connect B and D, that's a diagonal, or A and C. So that line segment that connects them. All right. Some other vocab review. A segment bisector is anything that divides a line segment into two congruent segments. Okay, for instance, the picture at the right, AB bisects PQ so that PF is congruent to FQ. Okay? Much like a segment bisector, an angle bisector is anything that divides an angle into two congruent angles. Okay? So for instance, picture at the right, we've got ray KM bisecting angle LKJ, and that results in angle LKM. Try that again. Angle LKM congruent to angle JKM. All right, so LKM here, JKM here. And then a perpendicular bisector. Not only does it divide a segment into two congruent parts, but it is also perpendicular to the segment. It's not meant to be tricky. Okay. But again, the picture at the right, AB is perpendicular to PQ, but it also bisects PQ. Okay. Now these two are specific to quadrilaterals and are going to be very important as we move into this next unit. Okay. Quadrilaterals have 4 sides and 4 interior angles. All right. That prefix quad meaning 4. Okay. Opposite sides are 2 sides that do not share any vertices. Okay. So for example, AD and BC are a pair of opposite sides. And then the other pair of opposite sides is going to be AB and DC. So they don't touch each other at all. All right. And then opposite angles are going to be 2 interior angles that do not share a side. Okay. So here we've got angle A and angle C. That's a pair of opposite angles. And then our other pair is going to be angle D and angle B. Okay. Opposite angles, opposite sides, diagonals, and then these consecutive angles are going to be very important as we move into Unit 14.